All right, we are going to get you going on page 301, and this is a cubic polynomial. It has all the stuff missing in the middle. So we notice it's the difference of two perfect cubes. I can tell that this is a perfect cube, but this isn't maybe as obvious to you. So we need to look at this as 10 to the third power. So 10 times 10 times 10 is 1,000. And on your colored paper of all the perfect squares and perfect cubes and stuff, it's there. So if you look on your colored paper at a different column, you will see it. So here's a colored paper, here's a pink one. And if we go down the list here, you got all your perfect squares, and then here's all your perfect cubes. So 1,000 is definitely a perfect cube. So 2 times 2 times 2 is 8, 3 times 3 times 3, etc. And then there's 10 times 10 times 10. So the factoring pattern for this is a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. So that's the factoring pattern. So what we're going to do is we're going to say, hey, what is being cubed here? That's your a. So what times what times what? Well, x. X is the what times what times what. And then b would be the what times what makes 1,000. Well, that's the 10. So you don't take the 1,000, you take what number is being multiplied together 3 times to make the 1,000. So the a and the b are going to get plugged into this factoring pattern right here. So a minus b be x minus 10. Then you plug your a there, which is the x. So you get x squared plus, then you multiply a times b together. So that'd be x10, but we don't write x10, we write 10x. And then b squared would be 10 times 10, which is 100. So this is now factored. Unfortunately, this doesn't factor again. So we're stuck with that. We get to use a quadratic formula on this side. So then I do zero product proper t, x minus 10 equals 0. And x squared plus 10x plus 100 equals 0. The left side is really easy to solve, but the right side requires the quadratic formula. So I'm going to drag in the quadratic formula on this. Quadratic formula, remember, is negative b plus or minus square root of b squared minus 4ac all over 2a. It's a little shiny. There we go. Now it's not shiny. So that's the quadratic formula. So a is equal to 1 because it's 1 there. B goes with the x, 10. C is 100. So x equals negative b plus or minus the square root b squared minus 4 times a times c. All over 2a, which would just be 2 times 1 is 2. Negative 10 plus or minus square root over 2. So that's 100, and then that'd be minus 400. So if you type in the calculator whatever you need to do, you get negative 300. Okay, so that's what the discriminant is. So there's no real solutions. I get imaginary solutions. Then the negative 300 gets split up into 3 things. And I told you I'd always do this with red. Well, this is pink, but close enough. Square root negative 1, square root, square root. So if I gave you 3 $100 bills, I know you would know that it was $300. So the perfect square that lives inside of 300 is 100, right? If you go back to your pink paper here, 100 is a perfect square, 10 times 10. All right. Now, we keep going. X equals negative 10 plus or minus 10 is this, Remember, that's the I. So it's 10I radical 3. All over 2. All of these are even. So you get x is equal to negative 5 plus or minus 5I radical 3 plus the solution over there. So you get 2 imaginary solutions, 2 complex solutions, and then 1 real solution. You may ask, where'd the 2 go? Well, when I do 2 divided by 2, I get 1. So this whole thing's divided by 1. All right, so I took the starting point here and I factored it, and then I went through. Now, I think this calls for some spinning, right? Isn't that fun? Okay, next problem. Next one's way easier than this. That's quite a bit, and there's only a couple more for you to try like that. 21. So this is my polynomial. I'm going to set my polynomial equal to 0 so I can factor it. That's what I'm still factoring. I factored this. It was weird factoring, but I factored it. So now I'm going to go to x to the 4th minus 8x squared, add the 16 over, equals 0. So now I'm going to factor it just like I did in the examples. So 2 sets of parentheses, put in x in each. That would be a lie. It has to make x to the 4th. So I'm going to put in x squared in each. It doesn't take too long to figure out that I need 4 and 4 to make the 8, so it's minus 4, minus 4. So since this is squared out here, these are the same thing times the same thing. I get that multiplicity idea. I get repeat solutions, because the solutions here will be the same as the solutions here. So I'm going to add 4 over and use the square root method to solve this. Plus or minus 2. And if I do the same thing here, I'm going to get x is plus or minus 2. So there really are 4 solutions. It's just that they're repeated of each other. So it's the whole multiplicity idea. All right, the next solution requires a graphing calculator. All right, this problem here we're going to solve by graphing. It's number 30. So you need a graphing calculator. If you don't have one, pause it or whatever. Clear and clear. Okay, typing it in. Oh, but before we type it in, we're going to set it equal to 0. Whoa, spinning calculator. Subtract over the 7x. We get 2x cubed plus 5x squared minus 7x equals 0. So we got to set it equal to 0 because we're going to find the zeros of the function where it crosses the x-axis. Okay, so I go to y equals, type in x, caret key 3, don't forget to push yourself out of there, plus 5x squared, you don't have to push yourself out of the squared, minus 7x. Okay, and we're looking for the places where it crosses, and hopefully we can find 3 places where it crosses. So we get our 3 solutions. So I'm going to hit the graph button. Oh, I'm going to do zoom standard, because I'm not sure what the last person did to this calculator. So hit zoom and then number 6. All right. So I got to figure out where it crosses. So it crosses here, here, and here. And it looks like it crosses at 1, 2, 3, 4, 5, 6, negative 6. Well, let's see if that's true. So I'm going to go to second calculate, and I'm going to do 0. So I got to get on the left side of the 0. There we are. And you can kind of see where you are by looking at the y values here. Like, see, I'm at negative 36. That's really far down there, so you know where you are. So if I can hit enter though, and it'll put a boundary, and you can go past really high if you want to. Enter, and see the boundary, the left bound and the right bound are on each side of there, and then come back and guess. And you can be bad at guessing. All right. Okay, I just realized something weird's going on here. I forgot to put the 2 in there, didn't I? So it's not really worth doing the whole video over again for a mistake like that. I am a human, I do make mistakes. So second insert and put a 2 there. There we go. That's what I should have graphed, is 2x to the third plus 5x squared minus 7x. My bad. Oopsie. Now I hit graph. Alright, so repeat the process again. Second, calculate 0 of the function. So I go over to the side over here, enter. Go to the right side, enter, back, guess. -3.5. So it crosses at a nice place, -3.5. So one of my solutions is x equals -3.5. And I need 2 more solutions. The other solution is kind of obvious, because if you put 0 in for x in all these spots, it would be 0. And you can see that it crosses at 0. And then the last one, it looks like it crosses at 1, but let's go ahead and go through the process. Second, calculate 0. Now I'm going to go after this one right here. Oops, this one right there. So go over. Okay, left side. Right side, and guess. 1. So those are the 3 solutions. It crosses at -3.5, it crosses at 0, and it crosses at 1. So there's 3 real solutions to this. So I didn't do the factoring thing, I solved it by graphing.